So the hyperbolic function of cosec x will be given by 1 over that, which is equal to that. Hyperbolic function of sec x will be given by 1 over cos x, which is equal to 2 divided by bracket exponential x plus exponential negative x, as indicated here. The hyperbolic function of cot is 1 over tan hyperbolic function of tan, which is given by exponential x plus exponential power negative x divided by exponential x minus exponential negative x. Now, with these 6 definitions, that is beginning with the hyperbolic function of sine, which is given by this equation, and that of cos, hyperbolic function of cos given by this, and that of tangent given by this, and that of hyperbolic function of cosec x, which is 1 over hyperbolic function of sine, which is given by this equation here, and that of hyperbolic function of sec x, which is 1 over hyperbolic function of cos x, which is given by this function, and that of cot x, which is equal to 1 over tan x, this one given by this. So with these six definition, we want now to find out how the derivative of this hyperbolic function it is arrived at. So welcome to the study as we do it right now. We want to start with number 1, so that f of x is equal to hyperbolic function of sine x, then its derivative will be given by hyperbolic function of cosine of x. So we are going to let function x to be represented by y, which is equal to hyperbolic function of x, and function x with this, which is given by this function here. So our derivative of f of x, we are going to represent it with y prime, which is equal to hyperbolic function of cos x. From the definition of hyperbolic function of sine x, hyperbolic function of sine x, which is given by exponential x minus exponential negative x over 2, and from the fact that derivative of any exponential function is the same function, we are going to differentiate this right hand side with respect to x to find. So differentiating this function with respect to x, and using the fact that exponential differentiated remain the same, we are going to get the first one. When you differentiate this function with respect to x, it will remain the same. When we differentiate this negative will come down here, so negative times negative is positive, so that is what we are going to get. But hyperbolic function of cos x is given by exponential x plus minus exponential plus exponential negative x over 2. So that tells you that the derivative of hyperbolic function of sine x will be given by hyperbolic function of cos x, as we were told to show that. Hence, the derivative of this function with respect to x will give us the hyperbolic function of cos x. So that is the end of the proof, which we have been told to show that given function x is hyperbolic function of sine x, then the derivative is cos x. So what you do, you begin by defining the hyperbolic function of sine, which is given by this function here, exponential x minus exponential negative x over 2, and you use the fact that exponential that differentiated it remain the same. So here we differentiate exponential x with respect to x to remain the same. When you did this, when exponential power negative x is differentiated, the negative comes down and this becomes positive. So we have shown that when you differentiate a hyperbolic function of sine x, the result is cos x. Number 2, we want to show that y differentiated is equal to negative of a hyperbolic function of sine x when we are given y is equal to a hyperbolic function of cos x. So we begin by defining the hyperbolic function of cos x, which is given by exponential x plus exponential negative x divided by 2. Divided by 2. So exponential power x plus exponential power negative x divided by 2. So we differentiate this with respect to x to remain with the same. When we differentiate this with respect to x, this will become negative x divided by 2. But from definition, hyperbolic function of sine x is given by exponential of x minus exponential of negative x divided by 2. So we have shown that y differentiated is equal to negative of sine of x when we are given function y is equal to a hyperbolic function of cos x. This is the case because in order for you to obtain this function here, you need to multiply it by negative, and when you multiply it by negative, you are going to get this function there.